Okay, and a good morning to everyone. And that was Buddy Holly, and that'll be the day, I believe. We have some questions, I think, that will be asked today on 7.5. That was where we were converting between American and metric system using dimensional analysis. So I want to do that, and just something that I spent about the last 20 minutes doing, and something that I would like to reference in terms of where we are heading. The material in the 8th chapter, I mentioned to you, involves percents. And it's essentially the percent unit we went through. And then it morphs into the simple interest unit we went into. And I think you're going to find it pretty much what we've done in two separate units. I've mentioned to you that this chapter 7 is dimensional analysis. And then there's this one chapter after that, which is graphing, which we did in the simple closed curve. So if we're looking at last 2 weeks of the semester, because I'm already thinking 2.5 weeks, you're going to find very little new. You're just going to find a lot of review. But one of the things I have encouraged you to do, and would encourage very much right now, is review dimensional analysis, review the percent unit, and, Michael will appreciate this, the simple interest unit. If you will review all 3 of those units this weekend, you should be in pretty good shape to finish the semester with a sense of comfort that you might not have felt in some of the preceding chapters we've covered. Now, having said that, you may have a discomfort level working between metric and the American system. And just to comment, if you're having that feeling, welcome to the rest of the United States. We have made efforts for 4 or more decades trying to make the United States more metric-oriented. And at one point, we even had highway signs that gave you the distances in kilometers. Don't see them very much these days, but I don't know that we'll ever change. But as far as this course is concerned, it's a prep for your science courses, your algebra courses, and so to that extent, we try to cover this conversion. So, Bomaro, question? I didn't set one up last time in the computer for the practice test. I've got to think about what I want to do that this weekend. It's not something that I want you to play with yet on the computer. What you need to be doing is going through the problems in the book. And I'm less and less enamored with the computer portion. So you need to be going to the problems in the book and carrying them through, writing them out, presenting your solutions. That is more important than anything you could be doing on the computer at the moment. So at the moment, we are now going to go ahead and look at 7.5 with questions and answers from that. James, you got the first one, I guess. Okay, we seem to have focused on the test suddenly. Okay, the test itself, we went up through 3.1 or 3.2, I believe, the last one. And so I think it's at about 3.3, right on up through. And then my question, in terms of what I want to do, I think I'm going to go up through 7.5 on the test. And then reserve the 8.1 through Chapter 9 for the final, plus questions from the first 3 exams. So the final is going to be 2 hours, so the one part of the final will be Chapter 8 and Chapter 9. And then I will choose roughly, say, 6 problems from, well, let's see, if we have 2 hours, 20 problems, there'd be 40 problems. Probably I'll go with around 30 problems. And so I would be inclined to have 6 from the first test, minimally 6 from the second, 6 from the third, we're at 18, and then 6 from each of the 2 chapters, roughly speaking. That's what my head is right now about the final and the next test. So if you think in terms of the next exam, that would be Chapter 7, 6, 5, 4. And if we look at that briefly, thinking of how you would prepare for that, and this weekend's a good time to do it, let me go ahead and come back to Chapter 3, what we were involved with. And there's a lot more algebra here than what we're doing in these later sections. So 3-4 was multiplying polynomials, prime numbers that you did in Math 10, the idea of factoring. So there are 3 very important sections there, at least, and then that, I'd say 4 problems easily from that material. Then if I slide down to Chapter 4, where we had equations and solutions, remember we did the addition process, we did the multiplication process, then we did word problems. So you're looking at maybe 4 from there. Coming off there for a minute, Jennifer, as I slide the camera down in Chapter 5. Again, this is where we started getting so much of the material that's redundant from Math 10. This was where you had fractions, mixed numbers, rational expressions, simplifying fractions, multiplying fractions, dividing fractions, and then we finally had, as we came off that for a moment, come back up to the top, we did adding, subtracting, and order of operations, and then we finally got something that I think you would perhaps think of in terms of algebra, sections 7 and 8. Then, as we come off there and come down to 6, where we again reviewed the idea of a rational number being written as a decimal, where we did the addition, subtraction of decimal numbers, the multiplying of decimal numbers, dividing decimal numbers. Square roots was the first part that I think was probably a challenge there. Then we had the order of operations and equations with decimals. So if I look at what we've been talking about in 4, 5, and 6, an equation, then equations with fractions, equations with decimals, if you just looked at the number of sections involved, you're probably looking at 5 sections from each of those chapters that I think would be important to test. And so with that, and maybe 4 sections from the first, we're close to 20 problems there without too much of a difficulty. In Chapter 7, which is what we're challenged with right now, and the whole idea in Chapter 7, and again, if we look at that, coming back to the document cam, the key perhaps to this is we went from dimensional analysis to a proportion. And in proportion we did by cross product. How much I want to do with what we are focused on right now, going from the American system to the metric system and then converting back and forth, it's not going to be a heavy concentration there. I would probably be inclined converting between the American and metric system more than I would be going in the metric from, say, a cubic centimeter to how many, well, if you have a cubic centimeter, so many cubic centimeters, how many liters do you have, where you have that 1 cc is 1 milliliter, and then you do the dimensional analysis. So as you think this weekend, I think, James, this is where I hear your question coming from. If you were going to review this weekend, you aren't going to want to put too many hours into 7. I will, as part of our tutorial tomorrow, have a quiz that will focus on probably the 7, 2, 7, 3, 7, 7, 3, 7, 4, and 7, 5. So 3, 4, and 5. And it'll be a brief quiz. So if I'm putting some heavy-duty study time in, I would go back to chapters 3, 4, 5, and 6 and put my time in there. And what I'm asking you to do is write some problems out. Don't spend it on the computer. You write a problem out, you show the steps, document your solution in a very positive way, and get used to that, because that's where we're getting chewed up on the quizzes. So if you spent the weekend doing that, and then you came back prior to the test and just said, okay, I'm going to look at every quiz problem we've had, and just go through and make sure you can do it, you understand what you're doing, that's going to be important, because that's where a lot of my focus will be. What have I asked in quizzes? That's what I thought important. And then come back and try to limit the number of problems to 20 maximum. And I may have fewer than that because I don't feel an obligation, just because we've covered a section on reviewing going from a common fraction to a decimal, of having you do that in an exam. So what I've tried to share with you yesterday, roughly 2/3 of what we do in every section is a review of Math 10. It's only that last 1/3, if you will, maybe even less, that is algebraic, pre-algebra. That's where I focus the quizzes, and that's where I will focus the exam. So the key here is you need to practice doing problems quickly, get them done in 3-4 minutes max per problem, because you'll have an hour. And if you think of that in terms of 20 problems, you have 3 minutes. Some will be a little bit shorter than the others. But does that answer the question for you about the test? And we're a week away from that. That's a week from today. But what I will be doing next week, I hate doing with then the test coming up, but I want time for you to get ready for the test. And it's lightweight. Keep talking about it. Let me show you, because that's where I'm going to go, and we're just going to answer questions today. I'm not covering new material today. But I'm going to go into 8.1, and I want you to look at it briefly to get some sense of what the future is going to be. 8.1. Okay. I'm on page 582. Look at the directions here on the screen. You are supposed to write this percent as a fraction. Now, you know the drill. Percent means over 100, 30 over 100, reduce, and you're done. That shouldn't terrify you. Change from this percent to a decimal. 58%, your rule of thumb. 2 places to the left, you're done. Okay, coming off there, here's a fraction, go to a percent. You've been there before. Either divide and make it a decimal, or, let's come back here one more moment, Jennifer. 3/4, you multiply the denominator by 25, multiply the numerator by 25, and you have 75 over 100, and you're done. Coming down to the next set, write the decimal as a percent. Again, you know the drill. 2 places to the right, and you're done. Okay, that was that set. I could say we're done with 8.1. Okay, so I hope you understand, and you are not going to feel terrified with that. Now, 8.2, number 9. 150% of 60 is what number? These are to be translated into equations. They are very simple. I don't want to belabor it. You can do them as what we've done before, but let's come one more moment, Jennifer, as I just look at this. The key. 150%, I need to get where the number is. So that's 1.5. I'm on page 588. So you take 1.5, of means multiply, so 1.5 times 60 equals the part, which you can call the letter P. So you're just going to translate these into very simple equations and solve them. We'll spend about 10-15 minutes practicing them, and again, you could do those each weekend without really much more than that. Michael? At this point, none of them are being treated as proportions. Now, it's not until the 3rd section of Chapter 8 where you actually, instead of doing our, remember we had the triangle, and then we also had percentage equals base times rate. Well, they're set up with this. I'm on page 590. Even the language is the same as we go to the document count. The percent of the whole is the part. Exactly the language I used in Math 10. So instead of treating it as a single formula and then just solving for one of them, it sets it up as a proportion. So if you look at it that way, here's the argument and here's your proportion. Because the percent is going to be over 100, right? Part over whole. So you have 4 pieces. One of them you don't know. Solve it as a proportion, cross multiply. That's the difference. That is the only new wrinkle in 3 sections, which takes us through Monday, Tuesday, and Wednesday before the test. Yes? No, it's Thursday. I set it up with the idea originally that I would go maybe up through 8.2 before I gave the exam. And after what we've been going through, I think I need to give you time. That's been very clear to me, that I can't push you right up to that window and then say, take the test the next day. So the nice part of this is 8.1, 8.2, and 8.3 is a cakewalk, I hope. And as such, you don't have to panic there. You can focus on your review, do this trivially because it's a review of what you've done before, and then take the test. And what's nice, you're nearly done with Chapter 8 by the time we go into the next week, which is do the geometry part that again is graphing that we've done in simple closed curve. We had a couple wrinkles, and then we just review for the final. So the tough part is over. I can sort of consider this as just treading water until the end of the semester, because all the material you've had just about is going to be familiar. Notation will be just a little bit different. But having just gone through the simple interest unit with the Math 10 group and looking at what's in here, same thing. Okay. So I hope that covers our discussion of the test, which is a week from today. Any other questions on that? I'm willing to entertain other questions, but I'm hoping that's about it. Okay, now, Q&A time. Yes. Kim, you start it off? Why not, right? Section 7.5, perhaps? Am I correct? Okay, so we're going to start with 7.5. And is there a particular problem you want to look at?
But it's in the computer.
Okay, so a computer problem. Are you going to share with me what it says?
I am. Let me find one.
Okay.
My cell phone.
Okay, while we're waiting for Kim to find it, you... Okay, but which one is it that we're dealing... Which one does it look like?
Yeah, I'll just give you an idea. Oh.
Okay.
It's 5/9.
Is this... Okay, we're using the formula for centigrade or Celsius and Fahrenheit. Okay. I understand where we are. Now let me go to the board. Well, let's first come back to the formula. So we have C and F, correct? Celsius and Fahrenheit. Now, what was each degree in terms of Celsius was the equivalent of what? 1.8 degrees Fahrenheit, right? 9/5. Wait a minute. So my point is, if I take 9/5 times my Celsius, it adjusts it to Fahrenheit, but because Celsius starts at 0 and for freezing, and Fahrenheit's going to start at 32, we just say, okay, I'll put 32 here to benchmark myself back to what freezing was for Fahrenheit and call this the formula. Now that's one of two formulas given to you. Now, if you just use that one formula, then I don't care whether you give me C or you give me F. I'll just solve for the other one, rather than memorize two formulas. Now again, I'm talking about paucity, trying to get by with a little less. That's the American way right now. Okay? Where the government would like us not to be so paucity concerned. Go out and spend. Interesting, they were talking about the G20 this morning. And what's very interesting is the contrast between Germany's reaction to a depression and the United States. When we had our depression in the 1930s, Franklin Delano Roosevelt brought us out of it by spending heavily. When Germany had its depression out of World War I, they had enormous inflation, and it created problems for them, which became the Third Reich, and so they are very cautious about spending money, creating inflationary problems. And we thought that's the way to get out of our problems because it worked for us in World War II, which is the way we got out of the Depression. So you have the two main protagonists, Merkel from Germany and Obama from the United States, seating at dinner together last night. Might have been good table talk. So with that, we come back to this problem. What is the conversion you want to do? 103 Fahrenheit. Okay, I'll just substitute that. Come over here. So you substitute, and now let your algebra work for you. So you want this term by itself, correct? So just subtract 32 from both sides. So I'm going to subtract 32 from here and 32 from here, or think of adding negative 32 to both sides. So what does that become on the left side? 71? So I have 71, and that's equal to 9 over 5 times c. Now, how do you get rid of a coefficient of this 9/5? You multiply by its reciprocal, or you can simply say divide both sides by 9 over 5. So this goes to 1, and I'll put the c in the left side. So I have 71 divided by 9/5, which is 71 times 5/9. And there's nothing nice about this because 5/9 was what from yesterday? 5/9 is what? The decimal with 5s forever. And so I'd be inclined to say, well, 9 goes into 71 darn near 8 times, and 8 times 5 is 40, so I'm just under 40. I wish. And so you take that, and there's no nice way of doing those 5s forever. So if you're going to carry it out the long way, you say 5 times 71, which is 355, and you divide that by 9, and you do a long division, is going to be 39 point something. 39s with 4s forever? Okay. Well, what is it telling you? If they had 39.44, then they aren't telling you wrong. They just tell them they didn't like the form you had it.
I tried 39.4, and I also tried 39.44, and that's part of the link.
Did they tell you to round up in the problem? If they said to the nearest tenth, then it would be 39.4, but it should have accepted it then. Okay, but... And you went to 40 and they said okay? There's not much of a defense for going up 5. Okay, but we're back to the same old story. Your problem isn't the math. Your problem is getting an agreement with the problem in the computer. So, how do you deal with that? 1, quit 2, 3 wrong answers and get a new problem and hope that it's easier than the last one or a little more accurate in terms of accepting what you did. Or you try to sort of control your frustration and say, okay, we'll talk about it when we come in. You're doing the right thing. And that's been my one concern, that I think too much of the energy and effort has gone into trying to take the computer on as a kind of protagonist, and you're going to get that thing to agree with you. And so 3 hours later, you're getting real angry at the computer, not the math. Now, that maybe is a good thing. Rather than being angry at math, be angry at a computer. But it's not helping you. So what you did was valid. Okay? We need a separate course, how to do computerized homework and live with the computer. Now, Sarah keeps telling me none of her students have this problem. I have a hunch they just keep hitting the button until it goes to a new problem they like, and they don't complain. Not that I'm concerned about that, but at dinner conversation, I get no understanding or empathy. My students don't have that problem. Going on. Any other questions on 7.5? James? Computer-based? Okay. The bane of our existence. Milliliters to ounces. Okay, now, if you're doing this in terms of what's in the book, I mean, they go to cups and pints and... No. I'm sorry. We're going to limit ourselves to some very basic equivalences, because I don't want you to sit there and memorize more than you have to. Paucity again. So what will be our equivalences that we want? Now let's just go through the number of them. 2.54 pinkies. And I note in reading the book that the pinky is given as a centimeter, approximately. So 2.54 centimeters for 1 inch. Okay, that's one of the crucial ones we have. Okay, and by the way, I used a dime for a millimeter as the thickness. They use the thickness of your nail. I like the dime better. But nonetheless, we have 1 kilogram was how many pounds? The 2.2 pounds. And then we did 1 liter was the 1.05 quarts, and I guess you use a 1.057. Is that correct? But I've been just using roughly a 5% on top, sort of a taxed quart. Use the 7 right now. Get used to it. Oh, it's clever, but get used to the 7, 1.057. Now that's pretty much it. Okay, so if I want milliliters and ounces, okay, a milliliter, in terms of ounces and quarts, the milliliters is the liter you can do, and the quarts and the ounces. So what do you need to know about ounces and quarts? Yeah, what is the equivalence for the number of ounces in a quart? 32 ounces in a quart for Math 10, your dimensional analysis. So we're going to start this just as we did in dimensional analysis. That's what we did in how much. Yep, the how much unit. Deja vu. Okay, so I want ounces. That's what I wanted. That's where I'll start. I'm going to use Oz for ounces. O-Z. And I know that I'm ultimately going to have to go back through here. So I think I'll just start with 32 ounces is 1 quart. And then I have, from these 3 I've made an effort to memorize, using the 1.057 quarts is 1 liter. And then I have 1 liter is 1,000 milliliters. And then I had, was it 25 milliliters at the beginning? Okay, so you had 25 up here. So 25 milliliters. So sliding over, the last fraction is 25 milliliters, and I'm there. Now you have to know that 1 milliliter is 1/1000th of a liter. So milli means 1/1000th. And that's where this 1,000 milliliters equals the 1 liter. So the liters are canceling, the quarts are canceling, these are canceling, I'm left with ounces. Okay. Now in that process, this 1,000 is not making me feel real happy. But I have a 32 times a 1.057 times a 1 times a 25, and it's over a whole bunch of 1s, 1,000, and a 1. And this we have to remember to put our ounces at the end. Now, that's the setup. Now, whether it works nicely and whether it agrees with what you're going to have on the computer is another issue, correct? Do you want to cancel here? And I have mixed feelings in that, because if I don't cancel, I can go ahead and get that product in the top and just move the decimal point 3 places over. And I dislike division compared to multiplication. Now, if I'm going to use a calculator, it's a wash either way. So this suggests that I'm going to have 32 times 25 times 1.057. Now, if I'm going to estimate, roughly speaking, every 4 of these is 100, and I have 8 of those, so I have 800 up here. So that's roughly 800 times 1 over 1,000. So I'm going to have about 8/10. So 0.8 is roughly my answer. Roughly. So I'm going to say 0.8 ounces as a rough estimate. Now, the rest of it is just a matter of multiplying it through. But does that answer the question of how I approached it? Yeah, and if you look at what's done in the text, they carry you through, assuming, I think, that you're going to have maybe a list of equivalences, and I don't play it that way. I want them in your head, so let's minimize the number you have in your head. So that's back to the three major ones. So, again, if they set it up in a particular way, and that's the only way they'll accept it, then trade it in for another problem. You try to get one that you're comfortable with. Richie. Yeah. No, I'm saying at this point with what I had here, if I didn't like this down here in the 1,000, I could cancel. From the 25, we'll go in there 40 times. Okay, so let's try some canceling. Now, my argument was if you just take the product in the top, then you can move the decimal 3 places over to your left because you've divided by 1,000 at the end. Well, I said you had 800 here times 1. That's 800. It's over 1,000. Move the decimal over 3 places, 0.8. Now, I'm going to do it instead. That was a rough approximation. Okay, I've multiplied 32 times 25 and got 800, and 800 by 1 is 800. Now, I've got a little bit more. I'm going to technically have 5% more, so 10% of 800 is going to be 80. 5% is going to be 40, so I probably have 840 over 1,000, which is 0.84. Okay, so this should probably be 840, and so 0.84. My intent was not to get it that carefully done, but let's do this now. 25 goes into there 40. And then it's very nice because 8 will go into here 5, and 8 will go into here 4. Okay, so now I have 4 times 1.057, and that's not too shabby. And then divide that by 5 at the end. So again, the question is, what are we battling here? And the real battle should be the dimensional analysis. The careful carrying through this at the very end is probably counterproductive for our time, but you seem inclined to have an interest there. So that's 28, 22, and I have a 4. So I have a 4228, and I'm going to divide that now by 5. So let me do it up here so we have room. 4228. I have the decimal in the wrong spot. So that's 0.8, and I have a 22. There's my 4. That gives me a 28, and so that looks like that's going to be about a 5. So I was off by my estimate by 5 thousandths. And I don't know whether they want you rounding off to tenth, hundredths, thousandths. Hundredths, so then we go 0.85. Okay? Is that enough, Richie, in terms of what you wanted, and James, what you wanted? And again, where should the focus be? Here. The setup. And again, what James is pointing out, they did so many ounces per cup, so many cups per pint, so many pints per quart, so many quarts per gallon, so many gallons per liter, so many liters per milliliters. No. I mean, you can do it. I don't deny that, but there should be an easier way. And this gets back to don't knee-jerk your way through a problem. Think. What kind of solution can you go through to save some time and make it a little bit easier on yourself? Other questions? Kim. And okay, so we're back to Celsius and Fahrenheit. Okay. Well, in this minute, I just need to have a moment so Jennifer can change. Okay, we'll stay here with this. And I'm going to go over here and have more fun with temperatures. Okay, remember our review? Let's see if you can remember, just because out of this you should have something that you remember forever about Celsius and Fahrenheit. Okay, if you're in the 40-degree range, what do you call it? The what 40s? Flaming 40s. If you're in the 30s, you call them the thirsty 30s. If you're in the 20s, you call them? No, temperate 20s. You don't tingle until your teens. And then you have the frosty 5s. So frosty 5s, tingling teens, temperate 20s, thirsty 30s, flaming 40s. And then start watching the weather forecast for Celsius and see if you can predict how you should feel that day. And that's without humidity or wind chill impact. Now, Kim, what is your 4 degrees above or below what? 2 degrees. Above? Above what? Okay, it's Celsius, so you're saying 2 degrees Celsius? But that's just it? And I want to know what that is in... Oh, okay, I want to go to Fahrenheit. So what am I going to do? Okay, Jennifer, if you'd be kind enough to give me the formula one more time on the left side of the front board. Okay. Michael, before we go there. No, I just use one formula. Why do 2 of them? That's been my argument. Paucity. Laziness. Mathematicians do believe in least effort, least common denominator. Not the greatest, the least. Okay, so we are going to back to the formula now. So we have F equals 9/5 C plus Fahrenheit, or I should say 32, curl. Okay, now I'm just going to plug numbers in there. So C is 2. 9/5 times 2 plus 32. Okay, so that's going to be, if you want, 1.8, right? So that's 3.6. 2 times 1.8, 3.6.
I like the way you, I set mine up different when I do it.
No, I understand. I'm just saying, answer the question. If I use one formula and use my algebra to keep me from having to memorize 2 formulas, I like it. It's in the same spirit that we said you had this one formula when we were working with percents, and if you wanted R, you solved for R. You divided both sides by B, and you said R was P over B. If you wanted B, you said you solved for B, so divided both sides by R. There are your 3 formulas by only knowing one. That, to me, is a kind of efficiency. That means you don't have to memorize so much garbage. Now, if you like memorizing that, then fine. And yes, I can do a different formula. I mean, one of the things I can say is, well, what would happen if you solved for C? That is, take this formula and now solve for C. So I have 9/5 C equals F minus 32. So multiply both sides by 5/9, and there's your new formula that is the alternate. And you get there very nicely just by solving one formula for the other. Don't want to push that too far, but I think there's something to be gained there. Enough? Okay. Michael. 2 times 1.8. Double 1.8 in your head. Okay, back to here. 9 over 5 we said was 1.8. So I just said if I had 2 times 1.8, that's 16, carry a 1, and 3.6. I was wanting you to do that in your head. Okay. But if you didn't like that, you could say 18 over 5 is 3.6. I just really like multiplication more than I like division. Okay. I sort of have Kyle's view of division like you used to have of fractions. I don't like division. Yeah, that's your part of equals the whole times the percent. Yeah, that's the same thing, and that's what we're going to be doing in this new chapter. We're hitting on percents. Just a reminder that this is part equals the whole times the percent. Rate is percent. Big R is little r is percent. Yes, you're right. Okay, other questions on homework? We're okay then? That was it? So in 7.5, we're, okay, Michael? No. Haven't even begun to fight. Okay. Do you have anything in there you're looking at in the problems in the book that gives you some sense of where you might anticipate some frustration? In 7.5. And I have a hunch that a lot of you will probably be trying to catch up on 7.5 this weekend. Just a thought. Okay, Michael, you have the problem there you want. Can you read it to me? Okay, so somebody from Japan claims to have a mass of 68 kilograms. Translation in terms of, we would say, weighs that much, but we call it mass rather than weight when we're in the metric system. Okay, so a person has a mass of 68 kilograms, and they're from Japan using the metric system. And we want to know what? So we're nosy. Yeah, we're nosy, and when I say, well, geez, I wonder what that is in pounds. So we're going to go to LBS, lubs. So what am I going to do? I'm going to do dimensional analysis, right? And you're right, I'm going to start with pounds. And remember the infamous 3 that I want you to have memorized? 2.2 pounds is 1 kilogram, and we have what? 68 kilograms done. Are we not? Well, that one wasn't bad enough. It's more, it looks more intimidating than it is what I'm trying to say. Because now what would you do? Multiply 2.2 times 6.8 and you're done. Okay, you want to give me a more challenging problem. Okay, let's go. $40 milliliters? Okay. And we want to go to ounces. Okay. Now, milliliters are the same as cc's. Okay? And you are given a very nice little transition in the text about, I believe, if you take a cc, it's about a quarter of a teaspoon. You have to read the material in there, but I think it says that at some point. So if we have 40, that's a lot. 40 cc's. I mean, I'm not sure this person's thinking well in selecting this problem, because if it's a quarter of a teaspoon for each cc, 40, that's 10 teaspoons. Chug-a-lug time. Okay, what am I going to want? Ounces, correct? Okay, so ounces it'll be. Now again, James, this is going to be a problem where I am sure that cups or something gets involved with what you're going to see in the computer. And what am I going to use? The ratio of the liters to the quarts. So I'm going to start with 32 ounces in 1 quart, and I'm going to go 1 quart is 1.05, 1.057 quarts, get the right spot. Quarts is 1 liter, and then what? 1 liter is 1,000 milliliters, and I had it times 40 milliliters. And now, do my dimensions cancel like I want? The quarts, yes. The liters, yes. The milliliters, yes. Okay. And I guess Kim would be saying, yeah, but you told me I had to use 1.057, so I better clean that up. There we go. Now, 40 times 32 times 1.057. So your 40 times 32, you said, was 1280. I agree with that. And we're going to multiply by 1.057. Now, note how I did this before as an estimate. It might not be a bad thing to remember. You can get an 0.5, that's 5%. Take 10% and take half of it. So 10% says move this over 1 point, that's 128, and 5% of that would be then 64. So it looks like I have 1280 plus 64 roughly, so that's going to be this as a rough estimate. Okay, which is 1344, and I'm dividing it by 1,000 now, so I have 1.34 ounces. Well, yeah, but if you treat 1057 as 105 and 5% is half of 10%, and you get 10% by moving the decimal one place over, that's Kyle's specialty with the percents, moving it over one place to the left and divide by 2. And I get a good approximation, and that may be good enough for your answer, because they're usually wanting these rounded off, it appears, to either tenths or hundredths. And so even though I've ignored the 7, my guess is I'm pretty darn close at 134. What is the correct answer at that point, James? Are you doing the calculator at that point? 1352, so I'm off in the hundredths position. So if it doesn't like 134, I'd try 135 and see if it accepts it and then go on to the next problem. I'm not going to fight the trivial when the key is the setup at the moment. But does that answer the question for you? And so again, you're going to find yourself in a conflict. Either carry through exactly as the computer is asking you to, or the text is suggesting, or try to limit the number of things you memorize. You know, we're back to that same argument. You know that 5,280 feet is in 1 mile. Well, how many yards? Okay, but you could do that just by multiplying by 1 yard over 3 feet and get it quickly. So the key is, don't clutter your head with too much trivia. Other questions in the homework? We're okay? How many of you have spent some time in 7.5? Just so I have an idea how many of you have worked. I know 1, 2 of you have. Okay, so you are sandbagging me, waiting for the weekend. Dangerous moves. Dangerous moves. Okay, tonight. Okay. But the homework that we're talking about for the tutorial tomorrow, also known as a quiz, 3, 4, and 5, and answering questions on 5, where most of you haven't done it, isn't really doing what I'd hoped today, which was getting really ready for the tutorial tomorrow. So it looks like tomorrow I'm going to be back to where? Answering questions in 7.5. Okay, so, well, high probability I'll be doing that. Okay, probability closer to 1 than 1/6. Is there anything else you want to ask from any of the sections right now? Those equivalencies? No. You just memorize the 3. Let's go back, Jennifer, to the infamous 3 under the clock. 2.54 centimeters equals 1 inch. 1 kilogram is 2.2 pounds, and 1 liter is 1.057 quarts. So those are the 3 I'm asking, plus everything you had in Math 10. Okay. No. Not, okay, let me make a disclaimer here. You can do dimensional analysis sometimes just as proportions, but most people have great difficulty running 3 or 4 simultaneous proportions. So to say that it can be set up versus you can do it with proportional thinking, 2 different animals. So on most of these, we are multiplying by unit factors to avoid doing it as proportions. You would have to run a sequence in that last problem of 4 separate proportions to carry it through. And I just don't think it's something that's why we're doing algebra. I mean, okay, algebra obviously is more than arithmetic. We use symbols. But we're looking at the structure of arithmetic. And then we're using it as a tool to solve problems that would be difficult otherwise. So doing dimensional analysis is a way of avoiding doing proportions, because proportions get messy the minute you get beyond the simplistic. Otherwise, if you are going 50 miles an hour, how many hours will it take you to go 200 miles? And you say, oh, 4. Because 4 times 50 is 200. That was easy. We can do those. But if I'm doing 57.5 miles an hour and I want to go 324.6 miles, how many hours an hour are you going to do? You aren't going to do that in your head. You resort to some kind of physical representation on paper, and you grind it out through a proportion and arithmetic. That's what we're arguing. That algebra is a tool that in many ways allows you to do thinking at a level that's challenged by stress. Because proportional thinking does get challenged by stress, and you tend to mess up the problems. Proportions gives you a nice way of getting out of that. And algebra allows you to solve problems. And I'm going to go back as an illustration here, since we're sort of out of questions in this part. And I'm going to go back over in the sideboard. So what I'm going to do is come back to a problem we did in the last quiz. And this had to do with a 4.5 and a 7.5 right triangle, and we wanted a side. Yeah. Okay, I'm just going to walk off camera here and go to the side. Just transition, if you will, there now, Jennifer. And we'll finish up with this problem. This was a problem with a right triangle that we had on the quiz last time. Yeah, the good old Pythagoras problem. And the argument was that I believe this was 7.5 in the diagonal, correct? And this was a 4.5 here. I guess the 4.5 should go down here. And this was unknown. And so the argument was x squared plus 4.5 squared is equal to 7.5 squared. Whether these were inches or meters, not the key. Well, then I ask you to remember a shortcut out of Math 10. 4.5 squared, 4 times 5 is 20, and then put a 2.5 after it. And then remember 7 times 8 is 56, so that's a 56.25. And then you want x squared by itself, so you subtracted 20.25 from 56.25. You got a 36, and then I said that should be clear to you that x is 6. Now, algebra allows you to construct a solution to that, document it, and think your way through it. Where you could have just said, well, I'll look at that, and it looks like it might be something. This is a way of carrying it through. It's not going to be clear to you that you get a 6 here and a 4, 5 here and a 7.5, that's 6 is not a number that's going to pop into your head. So that's what you should have done in that quiz. Michael, you have a look of... I don't have an idea in the world to answer your question at the moment. Because look at what I've done here, and I hope as you go back and look at that problem, it's going to seem reasonable to you. Well, did you get 20.25 when you squared it? And did you get 56.25? Ah, there's the problem, because 7 times 8 is 56. Yeah, and then that messes it up, and you don't get the nice number, and I rigged this one like crazy to make it work. I try to be nice to you in these quizzes. Sometimes. Okay. Okay. Remember when we did problems like this, I said, let's say you have 65 and you want to square it. What was the shortcut? Take the 6 and go to the next number, which is 7. 6 times 7 is 42, and then always put a 25 at the end. That was the shortcut we did in Math 10. Yes. Well, it's selective memory, but that was the, and then if this is 6.5, that's 42.25. So when I had 7.5, I said, we'll go 7 times 8 is 56, and put a 25 after it, And I was expecting you to remember that from Math 10 and do it. I do it every semester for at least a decade or 3. Oh, this is good that 4.5 inches was the size of the grid on the simple closed curve. So you should have remembered then that 4.5 squared is 20.25, and you multiplied it by the 45 or 50% of your points inside the curve. I'm pleased. Any other questions here before we give up on this? Now, again, tomorrow, you need to follow Michael's goal. Do 7.5 tonight if you haven't done it, because tomorrow you will have a quiz problem on it. And I will answer questions tomorrow, but if you haven't done them, you don't know what your questions are. Question. No. I didn't say that. I said these 3. 3, 4, and 5 will be the focus. Now, you will not have more than 5 problems on the quiz, and you'll have at least 1. So it's somewhere between 1 and 5 with probability of 99% that that's correct. So with that, no time left. We started with Buddy Holly. What is your quote?